Hello students, in this video we'll see an example of computing a probability using the joint probability density function. If we're given random variables x and y, with joint PDF, f of xy is a constant times x times e to the y on the region x between 0 and 1 and y between 0 and x. Find the probability that x plus y is less than or equal to 1/2. So what we'll do is let's first sketch the region where the PDF is defined. So the PDF is defined on the region x between 0 and 1. Here's the x-axis, here's the y-axis. So x goes between 0 and 1, and y goes between 0 and the line x. So this is the line y equals x. And so we're in this triangle over here. So x goes between 0 and 1, y goes between 0 and the x value. So this is the region of integration right here. That's the region that supports the PDF. And so I need to find that constant c. So let's find the constant c. So I know that the integral, x goes from 0 to 1, y goes from 0 up to x, of c times x e to the y dy dx has to be equal to 1. So let's do this integration. I can pull that constant out. So that constant comes out. I have the integral from 0 up to 1. And if I do a y integral over here, I'll have x e to the y from y equals 0 to y equals x dx. And this has to be equal to 1. And so we'll have over here c, the integral from 0 to 1. Of the top limit is x e to the x. And then the bottom limit is going to be minus x dx. So let's do this integral over here. So this has to be equal to 1. So 1 has to be equal to this. So this is equal to c. And then antiderivative of x e to the x is going to be x e to the x minus x, as we can check. And this just comes from integration by parts. And the integral of negative x is negative x squared over 2. And this gets evaluated from 0 to 1. So what we'll get over here is we'll have c. Then when I plug in x equals 0, everything is equal to 0. When I plug in x equals 1, I'll get a factor of e. Then a minus 1, then a minus 1/2. That is c times e minus 3/2, which is the same thing as c times 2e minus 3 over 2. Which tells us that c has to be equal to the reciprocal of this, so it's going to be 2 over 2e minus 3. That's our constant c. Now what we'd like to find, so now we know the exact form of the probability density function. My probability density function, f of xy, is exactly equal to 2 over 2e minus 3 times x times e to the y on our region. So that is our probability density function. And so what we can do now is we like to find the probability that x plus y is less than or equal to 1/2. So let's figure out what that region looks like. So if we look at the region, x plus y is equal to 1/2, that's the same as saying that y is equal to 1/2 minus x. And so that line looks like this. It has a slope, so this of course corresponds to 1. So the 1/2 is over here. That's 1/2. That's 1/2 over there. And so the line y equals 1/2 minus x looks exactly like this. It's just a straight line down from here to here. And so now I want the probability that y is less than or equal to this. So we're in this little small triangle right over here. So this is my region of integration. That's our region of integration right there. And so let's think about what happens in this region of integration. This region of integration, x, well, let's think about what x goes between. In this region of integration, y goes between 0 and 1/2, and x goes between this line over here and this line over here. So that first line, of course, is x equals y. So x goes between y and 1/2 minus y. If I solve this equation over here for x, this says that x is equal to 1/2 minus y. And so these are our bounds of integration. And so now to compute our probability, we put this all together. So the probability that x plus y is less than or equal to 1/2 is going to be the integral. I'll do the y bounds first. Y goes from 0 to 1/2. And then x is going to go from y to 1/2 minus y. And then what we do is we plug in our PDF. I'm going to leave c just as c over here. So we're going to have a c times x times e to the y dy is first. So we have these are our x limits. So our x limits come first. I have a dx, then a dy. And so what we'll do is we'll have the integral from 0 to 1/2. And then we'll have a c times x squared over 2, evaluated from y up to 1/2 minus y. And then this will be multiplied by e to the y dy. And so let's just do one more line. We'll leave it as a Calc 1 integral to do. And so this is just going to be c times the integral from 0 to 1/2 of 1/2, we'll put a c over 2 actually, 1/2 minus y squared. That's our first limit. And then minus y squared, that's our bottom limit over there. And then we'll have a e to the y dy. And so to finish this problem, all one needs to do is say that this, we can write this, of course, as just 1 over 2e minus 3, the integral from 0 to 1/2. And then if we expand this out, we'll have a 1/4 and then minus y. So this is going to be a 1/4 minus y. Then the y squared terms are going to cancel out. And then we'll have times e to the y dy. So to finish this problem, so this is our probability. To finish this problem and find a numerical value, we'll integrate this integral by parts and compute the numerical value. But the important thing is to understand how this region is set up. So the first step in these problems is always to find the constant of proportionality to define what the PDF is. Then sketch the support of the probability density function, find the condition that you're after, and figure out where the condition you're after intersects the support of the probability density function. That will give you your region of integration. Thank you very much.